Today, we're going to talk about a piece of tech that completely changed the game for the digital world, the Data Encryption Standard, or DES. It was basically the first public, government-stamped digital lock, and its story is this wild ride involving secret agencies, brilliant academics, and really the birth of modern cryptography as we know it. All right, so let's jump back in time a bit. Picture the 1970s. Computers are starting to pop up everywhere, right? They're handling everything from bank transfers to government secrets. But this incredible digital boom created a brand new, massive problem. How in the world do you keep all of that information safe? I mean, think about it. There was no single agreed-upon way to lock down all this digital data. Financial info, personal records, it was all just kinda out there. The world was desperate for a standard digital lock, something everyone could use and, more importantly, everyone could trust.
So the US government basically puts out a help wanted ad for a cipher. The first try in 1973, a total flop. Nobody had anything that was up to snuff. But on the second try, a year later, a team at IBM comes forward with this really powerful algorithm they called Lucifer. After a few years of review and some very secret tweaks we are definitely getting to in a sec, it officially becomes DES in 1977.
And just like that, the Data Encryption Standard was born. It became the go-to encryption algorithm all over the world, super fast. But its creation was packed with controversy, mostly because of the very quiet, very heavy involvement of the National Security Agency. Yep, the NSA. Okay, this is where the story gets really good. For years, the big conspiracy theory was that the NSA secretly weakened DES so they could spy on everyone. And they were kind of half right. The NSA did push IBM to use a shorter, weaker key. But the whole truth, which didn't come out for decades, was way crazier. Their other secret changes actually made the algorithm stronger. They were protecting it from a powerful code-breaking technique that they knew about, but the rest of us wouldn't figure out for another 20 years. Wild, right?
So, how did this thing actually work? How did this digital lock take perfectly readable info and just turn it into total nonsense without the key? Come on, let's pop the hood and take a look.
At its core, DES is what's called a block cipher. That just means it doesn't encrypt your data one letter at a time, it chops it up into fixed-size chunks, or blocks. For DES, that block size was 64 bits. And it uses the exact same 56-bit key to both lock and unlock the data, which is why it's called a symmetric key algorithm.
So the whole process really boils down to three main stages. First, it just scrambles the data block. Then comes the real magic. It puts that data through 16 identical rounds of serious mixing and mangling. The shredder analogy is perfect here. It's like you shred a document, then you mix up all the strips based on some secret rules, and then you do that 15 more times. Finally, it does one last scramble, which is the exact reverse of the first one.
So what's actually happening in those 16 rounds? It's this incredibly clever process called a Feistel network. It works like this. You split the data in half. You scramble one half using a special code, mix it with the other half, and then you swap them. And you do that over and over again, 16 times. That special code comes from the S boxes. That was the NSA's secret sauce. And from the key schedule, which cooks up a different mini key for each and every round. And the genius part of this whole structure is that it's completely reversible, which is how you get your original message back.
For a long time, DES was the absolute gold standard, but there was this shadow hanging over it from the very beginning, and it all came down to its key size. That one decision, pushed by the NSA, would eventually be its doom.
Almost right after DES came out, two absolute giants of cryptography, Whitfield Diffie and Martin Hellman, they sounded the alarm. They pointed to what they saw as a fatal flaw. They said, look, you could theoretically just try every single possible key until the message unlocks. This is what we call a brute force attack, and they warned that one day it would be totally possible.
The problem was the 56-bit key. Now, that allows for over 72 quadrillion possible keys. I mean, that sounds like an impossibly huge number, right? And it is. But Diffie and Hellman argued that as computers got faster and faster, that number would eventually be within reach. It was a race between the lock and the speed of technology.
And, just as they predicted, theory became reality. And it happened fast. You can see the timeline here. What starts as a huge distributed project in 1997 gets cracked in 56 hours in '98, thanks to a custom-built machine called deepcrack. By 1999, they got it down to just 22 hours. The race was over. Technology won. DES was officially broken.
So DES was cracked,
End of story, right? Nope, not even close. This isn't just some footnote about old tech. In a way, its failure is what gave birth to the entire modern era of public cryptography.
See, the fall of DES kicked off this big public competition to find its replacement. The winner was the Advanced Encryption Standard, or AES, and instead of a 56-bit key, AES starts at 128 bits. The difference there isn't just double, it is an absolutely astronomical leap. Trying to brute force a 128-bit key is so outlandishly difficult, it's just not going to happen with any technology we can even imagine today.
And this right here is the real legacy of DES. It was the first time ever that a really high-quality cipher was just out there, in public, for anyone to study. It gave the world's smartest researchers a common enemy to attack, and that huge collective effort basically jump-started the entire field of modern code breaking.
So by being that first big mountain everyone wanted to climb, DES taught us how to build even bigger, even more secure mountains. All those lessons are baked into the secure systems we all use every single day, when you check your bank account, send a message, or just browse the web.
So really, DES wasn't a failure at all. It was a necessary step, a first attempt that showed us how to build the Everest of security that we all rely on today. This explainer was created by Priyank Gada. If you found this useful, please hit that like button and subscribe for more. And be sure to check the description for some further reading. Thanks for watching.